Hello everyone, welcome to the Logical Loop channel, and today we will solve the lead code problem of the day. So the problem number is 3264 final array state after k multiplication operation 1. So you are given an integer array nums, an integer k, and integer multiplier. You need to perform the k operation on nums. In each operation, find the minimum value x in nums. If there are multiple occurrence of the minimum value, select the one that appear first. So like if there are like the minimum value like 2, 2, so we need to pick that minimum that 2 which have the index first, like on the 0 or on the 1. Okay, so we will need to pick the 0, 1. Replace the selected minimum value x with that x multiplier, this multiplier, and we need to repeat this process k times. Okay, so like this, if we can see this example, we have the 2 1 3 5 6 in operation 1. We pick the 1 and we multiply it 2, then it will become 2 2 3 5 6 in operation 2. We will pick this 2, we will pick this 2, and we multiply, sorry, we will pick this 2 because it on the index 0, and we multiply it by 2, it will become 4 2 3 5 6. Now we will pick this 2, we will multiply it by 2 to 4 4 4 3 5 6. Now we will pick this 3, then multiply it by 2, so it will become 4 4 6 5 6. Now the 4 4, these are the smaller ones, and this one is on the index first, like on the index 0, so we will pick this one, we multiply it by 2 8 4 6 5 6. Okay, and now let's see the constraint of this problem. So it is 1 till from 1 to 100. Okay, so let's discuss the brute method. Okay, so in the brute method, what we will do, first we will start the loop from k. We will and in that loop, we will find the minimum, and then we will find the minimum, and then we find the index of that minimum, and then we will multiply that index value, and we put into the nums. Okay, so root method. In this, we need to focus on the index. Okay. Root method into root k times, and in that we need to find the minimum value index, and then change it into nums. Okay, so let, and we will start a loop k times. In this, we will take a variable id which will maintain our smallest index, and in now we will find that smallest index. Okay, so if nums of I is less than num of I dx, we will give the smallest index to dx. Okay, now we in nums will change that idx value with multiplier. Okay, so nums idx multiply with multiplier. Okay, now we run the nums. Okay, what is saying multiplier is not a function. Okay, let's copy this thing and paste here. Okay, so now about the time complexity. Time complexity will be it's running till k, and in this we are finding the minimum one. So the time complexity will be k into n, and the space complexity is 1 because we did not take any uh, extra space to calculate. So we will submit it. So it is expected and 100% be 0. So now we will talk about the optimal approach. So in this, we need to find the minimum one again and again. So if we need to find the minimum one, we can use the min heap. Okay. So now let's solve with the optimal approach, because we need to find the minimum again and again, and we also need to find that index. Okay, so in the minimum heap, we will push the num that particular element with that index also. Use of min heap. In that we will push the element and with its index. Okay, so let for the nums dot length, let min heap equal to min heap, and now we need to first push the element and index. So for let I equal to 0, I plus plus, and min heap dot push nums of I and its index. Okay, so this will give you the complexity of login. Okay, so n is this loop and login is the operation of the pushing into the main loop. Okay, now the main logic, we will start the while loop till k times. Okay, in that we need to find the num. We will take out the num and index from the top of the min heap. So we will use the pole, and now in the nums idx we will multiply that num with multiplier, and we push this nums idx and idx into min heap for the next key operation. Okay, so min heap dot push nums idx and idx. Okay, we will return the nums, and now in the javascript there is no min heap, so we need to implement our own min heap. Okay, so let me implement that thing. Min heap classes are the syntactical sugar in the javascript. The main thing is happening in this constructor. Okay, just get parent index idx. This is how we find the idx of parent in the tree. Like many is kind of tree, and we need to find the parent index. So this is the formula to find the parent index, like math dot idx minus 1 and divided by 2. Okay. Get left child index, return idx divided by k, get right child index idx, swap icon I2. This is how we swap in JS. I2 and this dot data I1. Okay. Now we will write the compare method to compare when the value are same. So we will sort it out. We will sort it out according to that, according to the index. Okay. So if values are, if we compare according to the values, if we compare according to the values. Okay. So if, okay, sorry, if pair 1 and pair 2, if pair 1 is less than pair 2 first element, then return true. Okay, and if pair 1, like values are same and we need to compare by the indexes, pair 2, then we will return true and we do false. Okay, now we push method, we implement this dot data push pair, and now we call the heapify. We will add at the last and we will call the heapify up, heapify up, and heapify up. Here we define that thing. So let idx equal to this dot data dot length. We will take the index for that. We will start the loop till it's greater than 0. We will take the parent index, this get parent index, and if this, we will call that if this compare, and we will pass this data dot idx and this data parent. If this true, we will call the swap idx and parent, and for the further we will define idx with the next one. Not, we will break it out. Now pole, what min heap pole will give, it will give you the first element. Okay, so in the min heap the first element will be the smaller one. So if this dot data dot length equal to 0, we have nothing to return. If this dot data dot length equal to 1, we will return that last element, this dot data dot pop, let min value this dot data 0, and in that we will, in the starting one, we will push the last one pop call the ep5 down, ep5 down from the zero index, and we will return the min value. In ep5 down while true, let smallest equal to idx, let left child equal to this dot get left child index idx, let right child this dot get right child index idx. Okay, and now we will start comparing. If left is less than this dot data dot length, and in this compare we will pass this dot data left and this dot data smallest one. If that is true, in the smallest we will give you the left assignment, and now we will check for the right one. Data dot length, this dot compare this dot data right, and we will pass the smallest one for this also to compare with the smallest child, sorry, right child. And if true, we'll give you the right one. If smallest is not equal to idx, we will this dot sap idx with smallest, and in the idx we will give you the smallest one, else we will break it out. At last is empty, return this dot data dot length equal to 0. I hope I implemented the right. Okay, let's see. Okay, this dot data dot length, this acha, this is not defined. Where? Okay, null this data. Okay, so it is done. And the time complexity in this, for this it is n log n, and for this we are running the loop k times, and in that k time we are doing this operation push, so it will take the log n. So the total complexity is n log n plus k log n. If we optimize it further, like if we take it whole, so it we can write it k log n, and the space complexity is, we have take the min heap, so it will be n. Submit. Yep, done. So we have solved this question. Thank you everyone.